All right, so what we're looking at today, this is advanced functions. We looked at our first function last class, which is the absolute value function. What we're looking at here this time is the difference between what's called a relation versus a function. Every function is a relation, but what we're going to look at is when is a relation a function? So it works both ways. Now, a relation simply is this. It is a set of data, which is just points, that can be plotted on a graph. So you have any kind of information that can be plotted on a graph, that's your relation. What you want to determine is whether it's a function or not. Now, here's what I'm going to do. I'm going to be honest with you. I'm going to read this. This is going to not make any sense to you yet. Well, we are going to do several examples, and then I'm going to refer back to this note, okay? So again, this won't make any sense, but again, I'm going to come back to it. So a relation is a function if for every x coordinate, there is only one y coordinate. And I'm going to explain why that's important when we get to it, when we get to a question. We're also going to have two types of questions, questions where we get graphs and questions where we don't have graphs. So when we do have a graph, we can look at it as differently as that no 2 points can be connected by a vertical line. In other words, they pass this thing called the vertical line test. All right, again, doesn't make sense to you until we start doing some questions. Now, that is the first thing we are going to look at is we're going to look at different relations and we're going to figure out whether they are functions or not. All right, so let's tilt this a little bit. There we go. All right, now the second thing we're going to do for both a relation and a function is we're going to find what's called the domain and range. And the domain are the intervals or values of all possible x coordinates, where the range is basically the same thing, only we're talking about the intervals or values for all possible y coordinates. All right, so every question we're going to do, we're going to get a relation. We're going to figure out whether it is a function or not, and then we're going to find the domain and range. All right, which gets us to, whoa, getting fancy here, our first two examples. All right, so example 1. We're going to do 4 questions where we don't have a graph, and we're going to do 4 questions where we do have a graph, 4 examples. All right, so example 1, just as I mentioned, determine if each relation is a function and find the domain and range. Okay, so again, it takes a couple of these examples to figure out what's going on. Now, the first thing is that I have a set of data where we're talking about the altitude and the temperature. All right, so what we're looking for is, does every x have one y? And when I look, 0 has 10, 100 has 12, 200 has 15, 50 has 11, and 150 has 13. Now, in this situation, there is no repeats of an x value. So in this case, just from this simple data, and it's a very simple data, I'm going to say that it is a function. And it's because for every x, there is one y. We're going to get into examples where that doesn't happen. All right. Again, won't make sense for right off the bat. Now, what that is saying, when you say a relationship is a function is like predictability. I have an x, I get this y. There's no shady part there. All right. That's the big thing with a function, determining if a relation is a function. Predictability. I have an x, I get this y. All right. Now to the second part, the domain, where you're looking at what are all the possible x values that you could have. All right. Now, when you have a table of values like we have here, the x is always on the left and the y is always on the right. And so if I'm looking for what possible x's came from this experiment they did, or these measurements, well, they measured at an altitude of 0, they measured at an altitude of 100, and they measured at an altitude of 200, measured at an altitude of 50, and they measured at an altitude of 150. Those are the x values of where they took their measurements from. They didn't do a whole lot of measurements. but they did do 5 of those ones. Now we get to the other way. The range, same idea. What are all the possible Y values? What are all the possible temperatures that came from this experiment? Well, they got a 10 degrees. They got a 12 degrees, 15 degrees, 11 degrees, and a 13 degrees. All right, so from this experiment that this person did, we determined it is a function. There's only 5 values, so I guess it's sort of predictable in that, hey, if you're at an altitude of 0, the temperature is going to be 10 degrees Celsius. I would suggest doing more of an experiment if you're going to make that claim. All right, now we get to the next one, where we're measuring hair length, which is our X values here on the left, against height, which is our values on the right. All right, our Y values. And so now we're looking at, is this a function or a relation? All right, and so I have a hair length of 22, I get 172. I have a 30, I get 180. Hair length of 15, I have a height of 180. 4, I have a height of 176, 174, 15, 176. Now, here's the problem with this one. What you're trying to do, again, is predictability. If somebody has a certain hair length, they're going to guaranteed be a certain height. That's what you're looking with in a function. Now, you have to go by the data. But in this data, you look for repeats of x's. And we do have a repeat of an x. We got 2 15s. And the problem here is, or not the problem, but they're different y values. And so what that means is this is just a relation. And the reason, because we have to give a reason here, all right, is that for x equals 15, we get 2 different y values. We get 180 and we get 176. So there again, it's saying that this experiment, we can't say it's a function. It's not predictable. We can't predict. If your hair length is this, we're going to know what your height is. Makes sense, right? All right, so in this case, that's what's going on. All right, now the domain and range. Same idea as we did before. All right, well, the domain is what possible hair lengths could you have? Well, we had a hair length of 22, 30, 15, 4, that's more like me, 6, and then we have 15, but we already wrote 15 in there, so we don't have to write it again because it's just what's possible. We don't have to say, hey, it's there twice. We just have to say what's possible. So there's our domain. Range, same idea. Possible y values. So we have a 172. We have a 180. We already had a 180. We already wrote that, so I'm going to write it again, as I mentioned. 170, 174, and a 176. And there we go. So for those 2 examples, we determined whether it was a function or relation, found the domain and range. Again, if you have any questions, feel free to chime in there, particularly before I do my little squirt bottle. All right, like I said, we're going to do 2 more without a graph, and then we'll get into graphs where things are a little bit different. All right, next up, let's see here. All right, so our next graph, or next set of data. I don't want to ruin my markers here, so make sure this is dry. All right, so we got triple I. It's probably more common where our X is going to be defined as month of the year, and y is going to be our average temperature. And here's the data. We have 1, -18, which would be January. -18, 2, -18, 3, 5, 4, 10, 5, 16, and 6, 22. All right. Somebody want to, just from that information there, somebody want to chime in and make a shot at whether this is going to be a relation or a function? Nothing, eh? All right. Well, again, what you want to look at is the x values. Is there any repeats? No, there's not. So there's not even like those 215s like we had in the last example to compare. See if they have the same x. So again, this is a function. And again, you've got to state the reason. For every x, there is 1 y. All right, so then it's on to the domain and range. Anybody want to help me out with the domain, which again is all the possible x values?
I can help out.
Sure, thanks.
So would it just be like 1, 2, 3, 4, 5, 6?
It would be. You know what, I was trying to set you up there a bit, or somebody up? Because usually the answer somebody will always say is 1 to 6, which isn't true. Because we don't have 1.5 months, right? There is no month in between January and February. We don't have decimals. And so it just simply is whole numbers, 1, 2, 3, 4, 5, 6. All right. Range. Well, again, the range is the same idea where we're just stating which possible y values we have. We have a -18. Again, yeah, I'm looking at Sharon's answer there. Yes, we got 5, 10, 16, 22. So again, I didn't have to write -18 twice there. We already had it. And again, we're just saying what did come up in the data. That's it. All right, next one. IV. So our last one for data here. Where we're looking at what's called relation bubbles. Some of you may have seen this, maybe not. All right, so this is just a little bit different way to express data. I'm going to have to, what we're looking at, our X is our eye color. And Y is, I'm watching the old Blue Jays here, batting average. All right, so this is how these relation bubbles look. We got blue, put a little dot here, green, brown, hazel. Oh, I'm not giving myself much room here. All right, 280, 300, 318, 320, 340. Put that person on my team. All right, so why they're called their bubbles, I'm going to put them in a bubble here. All right, and then we do a little connection here. So I got this going down to here. There. There we go. There we go. Lines all over the place. Hopefully you got a good view of that. All right, so there we go. So the first thing, again, we want to do is determine whether this is this relationship between eye color and batting average is a function or not. Anybody want to chime in and help me out with that? Do you think this relationship is a function? And if you do, why? And if it's just a relation, why?
Right.
I'll go. It's not, because for each x, there's not one y.
All right. Which x?
Green.
Okay. There we go. Oh. Relation. Yeah, for green. Our x equals green, I should say, which is our x value. We got y equals, what do we got here? 280 and 320. Now, the funny part about this is that when I wrote this example many years ago, I thought, hey, obviously there's no relationship between eye color and batting average. It's actually not true, believe it or not. They did do a study of this like a couple years after I did this example. And does anybody know the difference, or happen to be a baseball player and know the relationship between eye color and batting average? It's a really small difference in the major leagues anyways. No? The relationship is that people with light colored eyes have trouble during the day. So it's actually that their batting average drops during day games. Who knew? All right. Now the domain. Oh, sorry. Yeah, the domain. Just trying to fit it on here. Well, domain, we're looking at all our possible eye colors. So we got our blue, green, brown, and the rare hazel. There we go. And then last one is our range. Which, I'm going to have to fit up maybe here. Let's get used to my new whiteboard here. All right, and it's all possible batting averages. So we got 280, right? 300. Again, we don't have to write them in numerical order here. 318, 320. And then this time, I'm not putting in 340 because it wasn't a result. No one hit 340, unfortunately. All right, so because there was no X value that went to that Y value, I just threw it in there. We don't write it in, all right, because it wasn't possible. And there we go. So that is our first four where we didn't have a graph. Now what we're going to go into is graphs and figuring out whether they are functions or relations, or sorry, if their relations are functions, and find the domain and range. One's it's flip-flop. One's easier than the other, comparatively to when you don't have a graph. All right, so let's see here. Get this all wiped down nice. Make sure this thing doesn't fall down. All right, so I guess I'll call this example 2 here. Like I said, we're getting into graphs. So example 2, same thing though. We are going to determine if each relation is a function and find the domain and range. So I'm going to try to use some old graphs here that hopefully you had a lot of experience with. And so we got I here. And let's see here, I'm going to draw. And let's see, try a different color here. Hopefully my colors didn't dry up over the summer. Might have to order some new ones here. So a little quadratic equation here where we got a parabola. There we go. All right, so there's our graph. And now what I'm going to do is I'm going to flip back to that original note that I said wasn't going to make any sense until we got to it. All right. Now, here we go. Hopefully nothing falls down on me here. All right. For a graph, we're going to find out if this relation is a function or not, is that no two points can be connected by a vertical line. Just in case you don't know what a vertical line is, we're talking about up and down. And so if I can draw a vertical line on it, and it only hits in one spot everywhere, it's a function. If at any spot I draw a vertical line and hits twice, now we've got a problem, and then now it's just a relation. All right. The other thing is, when we did not graphs, we got a lot of this, just values. But now we're going to be looking at intervals, because we're going to have decimals included, all the decimals included. So we'll get to that right now. And so there we go. When we're looking at our little quadratic here, the first thing is wherever I draw a vertical line, it always hits one spot. And so that means that our quadratic here is a function. And that is because it passes. So there's two different explanations. One for when you have data, just data, and one for graphs is that it passes the vertical line test, which I'm going to shorten it to the VLT. Let's be a little hungry here. All right, so it passes the VLT. So now it's a function. It means it's a function. All right, now the domain. Now, what's happening here is that this function, I drew this a specific way because we're talking about all the possible x values. And when I look at a quadratic, it keeps going up, but it also keeps going left. It never stops going left. And on the right, same idea, even though the parabola keeps going up, it still goes to the right. And so there's a couple of ways to say that is it's all real numbers. So a little funny are there. Or you get what's called interval notation, negative infinity to infinity. So there's two ways to look at it there. All right, or two explanations. Means every single x value is included in this quadratic. But now when we get to the range, that's not true. The range is all possible y values. Well, this parabola here, you see the vertex, using some old math language here for you. The vertex here starts at 2. This parabola never goes under 2. It never does. Because again, the range is the y values, the up and down. We're looking at the vertical here. And so what I'm going to say is that the y values are greater than and equal to 2. So that's where we get into intervals now, not just stating. Is that also correct? Yes. Same thing. X is a, when you write what you wrote there, X, and that funny symbol, it just says X, and that is an element of the real numbers. Same notation, same idea. I'm not looking to get too fancy here. I just want you to be able to write down, to analyze and be able to see what we actually have. Yeah, but that's just a fancy way of saying X is an element of the real numbers. The domain is all the real numbers. Same thing. All right, let's try another graph here. Let's throw in a little linear equation here. Sort of a linear piecewise. So draw our little graph here. All right, and start at -1. And let's see here. So we got tick 1, and 2, and 3. I don't think it matters. All right, so now we go draw my graph in here. So I'm going to put a closed, should be closed. Yeah, I did close. Closed circle. There we go. All right. So there we got our linear equation. All right, which stops though. Doesn't keep going, so it's defined. It has on a defined interval. All right, and I'm looking again to see whether this is a function or relation. And so when I look at it, vertical line test. By the way, the arrow just means it keeps going on the end. But Oh, that marker's shot. Garbage. All right. And so every time I draw a vertical line, it only hits the graph once. And so again, this is a function. Passes, we've got a graph here, the VLT. It passed the vertical line test. All right, but now when we get to the domain, whoops, domain, not a B. Anybody want to take a shot at it? What our domain would be for this particular function? Again, we're talking about domain, the intervals, in this case, of the possible x values. Left and right. Yeah, x is greater than, maybe we have a closed dot, and equal to -1. Starts at -1 and then moves right. Keeps doing it. All right, and now we get to the range. Possible y values, or interval of the y values for this particular one. Just checking out the chat as it look in here. Yeah, there we go. Again, y is greater than and equal to 0. Starts at the bottom level and then moves up because, again, the range is all about the up and down. All right, so there's 2 graphs. Let's try a couple more here. All right, so the first one I'm going to draw here. This one's a little tougher for me to draw. Let's see here. All right, so we got 6 spots. So 2, 4, 6, 2, 4, 6. All right, what we're talking about here is goals scored. And over here, games played. All right, so let's see here. I want to make sure I'm accurate to what I got going on here. Let's see here. So one person played 1 game, scored 3 goals. Too bad I didn't play more. 2 games. Somebody scored 1 goal. Somebody scored 2. Nobody played 3 games, but 4 games they scored 5 goals. Put that dot there. 5 games they scored 3 goals. And 6 games they only scored 1 goal. It's been a defensive player. There we go. So we got 6 players on there. All right. So what I'm looking at is this a relation? Is this relation a function? They're all relations because we can graph them. But is it a function? What do you think? Function or just a relation? And why? That's always key. Well, again, we're looking at, does it pass the vertical line test? Well, it does on one here. I drew a line through, but look at this. I draw a line through this spot. I hit twice. Yeah, it passes through 2 points at games played number 2, so that is a relation. Fails the VLT. Because we do have a spot where I can draw a vertical line and it hits twice. All right, then we get to domain. The possible X values. Well, the possible number of games played by people. And so in this case, well, somebody played 1 game. Somebody played 2 games. Nobody played 3 games, but somebody played 4 games, somebody played 5 games, and somebody played 6 games. What you will notice here in this example is that I didn't do the intervals because you can't score or you can't play 1.5 games, right? You might say that, but in terms of actual statistics, as soon as you step on the field, you played a game. You can't play part of a game. All right, range. Well, again, the range is our up and down, our vertical values. All right, in this case, how many goals were scored, or who scored what kind of goals? Well, 1 goal was scored by 2 people. 2 goals was scored by somebody. 3 goals was scored by 2 people. And nobody scored 4 goals, but then somebody did score 5 goals. And there's our range, possible values of what people could have scored. All right, so one more here, one more graph. Let's try to throw every scenario at you here. That way you're not surprised when you're doing your homework, which is always kind of helps. My opinion anyways. I don't think every teacher looks at it that way, but you never know. All right, last one. Let's see here. Again, I'm going to draw a graph. So this is, whoa, that's like, wipe that down. All right, so here we go. IV. All right, so let's see here. We go 1, 2, 3 out there. 1, 2, 3 left. Means -3. And then we got 1, 2, 3, 4, 5 down. Of course, means we're going to go 1, 2, 3, 4, 5 up. All right, now for me to draw this in. All right, so let's see here. There we go. Funny looking thing. All right, so now again, here's my relation. It's information I can graph. So I'm looking at, is this relation a function? And if it is, it's a relation. It fails the VLT. That is true. All right, so there we go. And in fact, it doesn't matter where you draw a vertical line on this one. You're going to hit this graph twice anywhere. Not just one spot, anywhere. So it fails the VLT. Now, this is where we get a little things that we haven't had this yet, the domain. We're looking at the possible y or the x values, right? Left to right. Well, every spot from -3 to 3, there's an x value. So there's a couple ways to write it. So I'm going to write it the easy way first and then the combo way the second. So it's up to you. It doesn't matter which way. So first off, it never go past 3, this graph. So x is always, and it hits 3, so it's going to be less than or equal to 3. But it never goes past -3 either. So I'm going to say that x is also greater than or equal to -3. Now, you could write this as, you put x in the middle. Well, x is greater than or equal to -3. I'm just combining the twos. That's all I'm really doing here. But x is less than or equal to, same thing. They're exactly the same thing. All right, now the range. Well, somebody want to help me out with the range now? That's our up and down. We're definitely going to be looking at an interval here. Just check out the chat. So what would our range be for this particular one? Y is less than or equal to 5. Yeah, that would be the first part. And then the second part, yeah, we have x is greater than or equal to -5. And again, I could write it as taking them and combining them, where you get this part here where x is less than or equal to 5, which is true. And then you have x is greater than or equal to -5. Well, I can write it this way. And there we go. So again, that's what we're doing today. We're looking at each relationship, determining whether it's a function, and then finding the domain and range. And it doesn't matter whether it is a graph or just a set of data that's in a table of values, listed as points or a relation bubble. And there we go.